isothermal irreversible expansion. Isothermal irreversible expansion. So irreversible process means any process which continuously takes place without the need of maintenance of equilibrium with the system and surroundings is called irreversible. Next, here isothermal means when a process is taking place, if temperature is maintained constant, that is called isothermal. Therefore, at constant temperature, the gas can undergo expansion either reversibly or irreversibly. For a reversible expansion to take place, the basic requirement is the pressure difference between system and surroundings must be very large. Therefore, P external is equal to P internal minus dP. Here, where dP is very large, dP is very large. Therefore, P external is not at all equal to P internal. P external is not at all equal to P internal. Therefore, work involved is minus P external dV. P external dV. Next, if gas undergoes expansion from V1 to V2 in a single step, undergoes expansion from V1 to in a single step, therefore the total work is equal to minus P dV integral of V1 to V2. Therefore, since the expansion is taking place in one step, therefore minus P V2 minus V1. Here this is P external. This is therefore the work involved is equal to minus P external V2 minus V1. Here V2 is greater than V1, therefore this expression will remain negative. Since V2 is greater than V1, therefore the above expression will remain negative. If the expression remains negative, that indicates the gas is doing some work, the gas is undergoing expansion, the gas is spending its own internal energy. The above expression will remain negative. If the expression is negative, it shows that some amount of energy is being spent off. Irreversible isothermal irreversible compression. That means in the isothermal irreversible compression, the gas is coming back to its original position. That means in the expansion, the gas has undergone expansion from V1 to V2. After reaching V2, again the gas is coming back to the V1. During compression, the surroundings, by using their energy, they will compress the gas. Therefore, during the isothermal reversible expansion, for compression to take place, the P external must be equal to P internal plus del P. Here, where del P is very large. That means P external is not equal to P internal. Next, work involved. Work involved is minus P external dV. That is equal to minus P external dV, because gas is undergoing compression from V2 to V1. Therefore, here final volume is V1, initial volume is V2. Therefore, minus P external V1 minus V2. V1 minus V2. Here the magnitude of V2 is more and V1 is less. That means this is less and this is more. So therefore, this is a negative quantity. Negative into negative becomes positive. Therefore, here since V1 is less than V2, therefore the above expression become positive. The above expression becomes positive. Next, when expression becomes positive, shows that the surroundings are doing work on system. Next, total work, W total is equal to work involved in expansion plus work involved in compression. Work involved in the expansion minus P external, here V2 minus V1. Next, plus minus P external V1 minus V2. Next, P external V2 minus V1 plus P external. I will represent this as see, this minus P external V1 minus V2. If you multiply this whole term with the negative sign, this V2 will become positive, V1 will become negative. Therefore, P external V2 minus V1. Next term, so V2 minus V1, here V2 minus V1. So let us separate this as a common term. Next, here this is positive and this is negative. This is P external during compression minus P external during expansion. See, P external during compression. See, if the gas undergoes expansion from V1 to V2, and again if it undergoes compression from V2 to V1, here during the irreversible expansion, the gas will undergo expansion against the lower pressure. That means here, if for example, if the pressure of the gas is 10 atmospheres, if the gas undergoes expansion, finally the pressure of the gas, let us say it has become 1 atmosphere. That means in the irreversible expansion, the gas is undergoing expansion against this 1 atmosphere. That means during expansion, the magnitude of the external pressure is less. Next, during compression, the gas has to undergo a compression against this pressure. That means the magnitude of the external pressure during compression is more. That means, so this magnitude is more and this magnitude is less. Therefore, more minus less positive. This is also positive. So therefore, finally, we got the positive result. That means when the total work is calculated by summing the expansion work and compression work, we didn't get the negative. Sorry, we didn't get the zero. We got the positive. So therefore, whether if you get the positive or negative, then that process is not described as the perfect cyclic process. Since result is not zero, therefore the process is described as not perfect cyclic process. Not cyclic process. Therefore, it is not It is not a state variable. State variable.